Imagine a world where it rains liquid gas, where giant sand dunes are made of frozen organics, and where the raw ingredients for life might already be brewing in the freezing dark. This isn't a sci-fi movie. This is Titan, Saturn's most mysterious moon. And to explore it, NASA is about to do something almost unbelievable. They are sending a car-sized, nuclear-powered drone to actually fly through its dense alien skies. Make sure you stick around until the very end of this video, because we're going to break down the absolutely terrifying, do-or-die mid-air drop this machine must pull off just to survive the landing, and how its ultimate destination could reveal a completely bizarre, exotic form of alien life that breaks all the rules of biology. You won't want to miss this. Imagine a world almost 1 billion miles away from the warmth of our sun, a place shrouded in a thick, golden, hazy atmosphere, hiding secrets that have puzzled astronomers for decades. This isn't just another barren rock floating in the void of space. This is Titan, Saturn's largest moon, and it might just be the most fascinating piece of real estate in our entire solar system. For years, we could only look at it from afar, wondering what mysteries were buried beneath its dense, smog-like clouds. When the Cassini-Huygens mission finally pierced that veil, what it found was nothing short of staggering. It revealed an alien world that is incredibly, almost eerily, similar to our own planet. Titan is the only other place in the solar system known to have an Earth-like cycle of liquids raining down from clouds, flowing across its surface, and filling massive lakes and seas. But there's a massive catch. The rivers carving their way through Titan's icy mountains aren't made of water. In the bone-chilling cold of Titan, where surface temperatures plunge to negative 290 degrees Fahrenheit, water is as hard as granite. Instead, the liquid that rains from the sky and pools in massive alien oceans is composed of liquid methane and ethane. Titan is a frozen time capsule. Its bizarre, chemistry-rich environment is widely believed to resemble what a primordial Earth looked like billions of years ago, right before life began. The surface is literally coated in the chemical building blocks of biology. If we want to understand how organic chemistry transforms into living organisms, how non-living matter somehow sparks into life, Titan is the perfect planetary-scale laboratory to find out. But exploring a world this complex, this rugged, and this far away requires something completely revolutionary. You can't just land a traditional rover with wheels and expect it to cover enough ground through methane bogs and towering dunes of organic sand. To truly unlock the secrets of Titan, you need to take to the alien skies. You need a vehicle that can fly, land, analyze, and then fly again. Enter NASA's Dragonfly. Conceived as one of the most audacious space exploration missions ever attempted, Dragonfly isn't a wheeled rover, and it isn't an orbiting satellite. It is a massive, car-sized, nuclear-powered rotorcraft. Designed to soar through Titan's dense, nitrogen-rich atmosphere, this robotic pioneer will leapfrog from location to location, exploring dozens of diverse environments. It represents a massive leap forward in how we explore alien worlds, taking us off the ground and into the air. Flying a car-sized robot on another planet sounds like science fiction, but the physics of Titan actually work heavily in our favor. In fact, flying on Titan is significantly easier than flying on Earth. The moon's atmosphere is about 4 times denser than ours, providing incredible lift, while its gravity is only about 1/7 of Earth's, even lower than the gravity on our own moon. For a rotorcraft, this combination of heavy air and light gravity is an absolute dream. allowing Dragonfly to soar through the alien sky with remarkable efficiency. To navigate this thick, smoggy air, Dragonfly is designed as an octocopter. It features 4 pairs of large, stacked rotors positioned at its corners, making it look like a heavy-duty, futuristic drone. This dual rotor design offers vital redundancy. If one motor fails in the harsh, freezing environment, the mission doesn't abruptly end. When it takes off, it will cover miles in a single flight, flying higher and farther than any wheeled rover could ever hope to travel in a lifetime, mapping the alien terrain below in breathtaking detail. But how do you power a massive flying laboratory nearly 1 billion miles from the sun? Solar panels are completely useless out here. Titan's thick, hazy atmosphere blocks most sunlight, plunging the surface into perpetual, eerie twilight. Instead, Dragonfly relies on a proven powerhouse, a multi-mission radioisotope thermoelectric generator, or MMRTG. Simply put, it's a nuclear battery that converts the heat from decaying plutonium into electricity. This steady, reliable power source will keep Dragonfly's systems warm and its batteries charged, allowing it to fly, drill, and analyze data night and day. Controlling this nuclear drone, however, presents a monumental challenge. Earth and Saturn are so incredibly far apart that a simple radio signal takes over an hour just to travel one way. There is no joystick, no real-time piloting, and no remote control. When Dragonfly takes to the sky, it is completely on its own. It will use advanced, built-in artificial intelligence and autonomous navigation systems to plan its flight paths, identify hazards, and choose safe, level ground for its next landing, all without any human intervention. When this robotic explorer finally arrives in the mid-2030s, its epic journey will begin in an equatorial region known as the Shangri-La Dune fields. If you were standing there, it might look surprisingly familiar, closely resembling the sweeping, wind-sculpted sand dunes of Namibia here on Earth. But remember, the sand here isn't made of silica or quartz. It is composed of dark, complex organic particles shaped by gentle methane winds. This vast, relatively flat region provides a safe initial landing zone to test the rotorcraft systems before venturing into more rugged territory. From the dunes of Shangri-La, Dragonfly will execute a series of daring, leapfrog flights toward its ultimate destination, the Selk Crater. This massive geological scar is a place of extreme scientific interest because it is an impact crater. When an object slammed into Titan millions of years ago, the immense heat of the collision melted the moon's icy crust, creating temporary pools of liquid water. Here, liquid water and organic molecules mingled for thousands of years. If there was ever a place on Titan where the spark of prebiotic chemistry might have ignited, Selk Crater is it, and Dragonfly is going right to the source. Once Dragonfly touches down at a new site, the real detective work begins. Unlike an orbiting satellite that can only stare at the surface, this rotorcraft gets its hands dirty. Resting on its specialized landing skids, it will transform from an agile flying machine into a highly advanced stationary chemistry lab. At each new location, it will study the terrain using a suite of high-resolution cameras, giving us panoramic, bug's-eye views of a world no human has ever seen up close. But the most exciting part isn't what Dragonfly can see, it's what it can dig up. To access the secrets buried in the alien soil, Dragonfly is equipped with a specialized rotary percussive drill system. Imagine a high-tech miniature jackhammer spinning at incredibly fast speeds, specifically designed to bite into Titan's rock-hard, cryogenic ice and organic sands. As it drills, a pneumatic system, essentially a highly precise space vacuum, sucks the frozen shavings directly up into the belly of the rotorcraft. It's an ingenious piece of engineering, built to handle materials that would instantly melt or alter if exposed to even the slightest bit of heat from the drilling friction.
Once those icy organic samples are pulled inside, they are fed into the heart of the machine, a highly complex instrument known as a mass spectrometer. This onboard laboratory will zap the alien dirt with lasers or bake it in tiny ovens, breaking the material down to identify its exact chemical makeup. Scientists back on Earth aren't just looking for random carbon molecules. They are hunting for amino acids, lipids, and other complex structures. They are searching for the literal molecular blueprints of life, trying to see exactly how far the prebiotic chemistry on Titan has progressed. But Dragonfly's mission isn't limited to scratching the surface. It will also listen deep into the moon's interior. Built right into the landing skids are highly sensitive seismometers designed to detect vibrations and acoustic waves from deep within the moon. By listening for Titanquakes, scientists can map out the internal structure of this bizarre world. This is crucial because scientists strongly suspect that deep beneath Titan's thick, freezing crust of water ice lies a massive global ocean of liquid water, potentially holding a greater volume of water than all of Earth's oceans combined. While it waits for its nuclear battery to recharge for the next flight, the rotorcraft will also serve as the first ever meteorological station on Titan. It will constantly monitor the alien weather, measuring the atmospheric pressure, the temperature fluctuations, and the speed of the gentle, dense methane winds blowing across the dunes. It will even track the moon's unique humidity, looking for signs of incoming methane rainstorms. By combining these weather reports with the chemical data and subsurface scans, Dragonfly will give us the most complete picture ever painted of this weird, wonderful moon. Getting this nuclear-powered laboratory to the surface of Titan is an epic saga in its own right. The journey begins with a thunderous launch from Earth, hurling Dragonfly into the cold, silent void of deep space. But space is inconceivably vast, and Saturn is incredibly far away. This isn't a quick 7-month trip to Mars. This is a grueling, multi-year voyage across hundreds of millions of miles of empty space. For the scientists and engineers who devoted their careers to building this machine, it will be a long, nerve-wracking wait, filled with precise course corrections and silent anticipation as the spacecraft coasts toward the outer solar system. The absolute true test of nerves comes on arrival day, when Dragonfly must plunge through Titan's thick, hazy atmosphere at hypersonic speeds. Encased in a protective aeroshell, it will endure intense friction and blistering heat as it streaks through the orange sky. As the atmosphere thickens, massive parachutes will deploy, violently slowing the descent. But the most terrifying moment happens thousands of feet above the ground. The aeroshell will detach, and the massive rotorcraft will simply drop. In midair, it must fire up its 8 rotors, stabilize itself in the dense alien winds.
Touching down safely is only the beginning. Simply surviving on Titan is a continuous engineering marvel. A single day on this moon lasts nearly 16 Earth days, meaning Dragonfly will have to endure relentless, frigid, pitch-black nights that drag on for over a week at a time. In temperatures cold enough to shatter conventional steel, keeping the internal electronics from freezing solid is a constant battle for survival. The spacecraft will effectively bunker down, routing the precious, life-saving warmth from its nuclear battery to its most vital components, hibernating through the long, dark alien nights until the dim sunlight finally returns. But braving these brutal conditions is worth the monumental risk, because Dragonfly is hunting for something that could fundamentally alter our understanding of the cosmos. While the moon's deep subsurface ocean might harbor Earth-like life based in water, astrobiologists are equally fascinated by what might be happening right on the frozen surface. Could there be a completely exotic form of biology that breathes hydrogen and drinks liquid methane instead of water?
finding this kind of weird life, organisms that operate by a completely different set of chemical rules, would prove that life in the universe isn't a rare anomaly, but a cosmic inevitability. Whether it finds exotic microbes or simply the complex chemical precursors to biology, Dragonfly is poised to rewrite the textbooks. We are finally moving past the era of slow-rolling rovers that are constantly constrained by jagged rocks, deep sand, and steep craters. By taking to the skies, we are unlocking the ability to explore distant worlds on a scale and at a speed never before imagined. This mission is a bold testament to human ingenuity, proving that we are no longer just staring at hazy dots through telescopes. We are building flying machines to conquer their skies. What do you think Dragonfly will find hidden in the freezing dunes of Titan? Exotic alien biology, or just the quiet echoes of a frozen world? Let me know your theories down in the comments. If you enjoyed this journey to the outer solar system, hit that like button, subscribe to the channel, and turn on notifications so you never miss our next great adventure into the cosmos. Thanks for watching, and keep looking up.